Hello everyone, I am Priyank Pathak from CRCV lab of University of Central Florida, and today I will be presenting our work Color See, Color Ignore, a close changing ReID with color disentanglement. The QR code will take you to our project page. The problem statement we are solving is close changing ReID. Basically, it means of identifying a person irrespective of change of clothes, that is ignoring appearance bias. Appearance bias can be clothes or the environment, and the motivation is that in real world people do change their clothes. So where the current research is they try to learn clothes embedding somehow, and clothes are generally represented as integer labels. So let's say person A is wearing cloth ID 0, and the model is supposed to predict these classes, class 1, class 2, class 3, and this is true for almost all the works. And the problem with this is these integer labels are non-descriptive. They do not tell you what the person is wearing. They are non-informative. And general tradition is you since you have no awareness of what the person is wearing, the entire video is assigned one clothing label. Even if the person changes their clothes in the middle of the video, the person is still assigned a one constant label. Then the second thing is the new recent method of LLM, large language model based fine-grained clothing attributes. They are computationally very heavy, but they tell you the exact appearance of a person in that particular frame. Now the question is, what happens if the person changes their appearance during a video? Let's say the person removes their black hat. This fine-grained appearance will change, and you will have to continuously run these LLM models on the video throughout the video. This makes them non-scalable. So what do we do here is we propose using colors as a substitute for clothing labels. How does clothing colors work? Colors basically have the property to cluster the images or frames or video frames based on similar clothing. These are the two examples that we are showing. On the project page, you will see a lot of GIFs of such samples where the color was used to cluster people based on similar clothing. Then colors have the property of being efficient. They can be efficiently extracted from RGB images. And one beauty of them is they are RGB only. They do not require external modality. They are purely extracted from RGB pixels. They are free of cost. They do not clothing, unlike clothing annotation, which requires some form of annotation device or LM cost. These colors can be extracted free of cost, and they are annotation free. Any data set on this planet can be used to extract colors. Colors are also contextual. Basically, same similar background that or similar lights settings and similar foreground. They have tend to have similar color histogram, and then they tend to form similar clusters. Colors are also adaptive. Let's say in this for this example, let's imagine there's this blue person, blue shirt, blue jacket, gray pant, and during the course of the video, this person removes the blue jacket. These two forms different clusters. A clothing label cannot make this distinction. Colors can. So how do we represent colors? Colors can be simple, counting the number of pixel in each channel. This is we call as pixel binning. And then colors can be a little complicated, 2D projections. This is mostly used in style GANs. We call this RGB UV projection. And on the side, you can see the examples of what they look like. Now, our method color see, color ignore is a transformer based approach. And it's designed to be very efficient. And one key property that we follow here is it has to be one model. Traditional ReID methods generally use two branches, one for appearance bias and one's for ReID biometric. In this design, we tend to follow only one branch system. So you have an XI image of a person. It is converted into spatial RGB patches. It passes through linear projection, which makes it spatial embeddings. Then a class token is generally added in a transformer. In the space of ReID, we call this class token as ReID token. And it passes through a series of transformer n blocks. And then you have final embeddings. The final class token or ReID token embedding is called ReID embedding, FReID. In traditional ReID, it is generally trained with an ID classifier, which is supposed to classify what individual this person, which class, what this individual is. Then it has a triplet loss, which is a contrastive loss used traditionally in all ReID models. And this FReID is used for inference. In our approach, we introduce one more class token. This is known as color token. And it follows a similar trajectory like every other token, and it's supposed to generate your color embedding. And the idea is it passes through a MLP layer, fully connected multi-layer perceptron, just like an ID classifier, which the RGB image can be used to project color histogram, which can be a 1D flattened vector. And the projection can be learned so that you have a fully connected network using regression laws can learn color embeddings. And then we can simply disentangle. One more novelty of our design is a special kind of self-attention known as S2A self-attention. Now, what is S2A self-attention? In the traditional self-attention mechanism, every token interacts with every other token. The ID token will interact with color tokens will interact with spatial tokens. This has a problem of 100% information leak. That biometrics information is being leaked to color tokens, which is representing appearance bias, and vice versa. Appearance characteristics are leading to biometrics, which think about a scenario for a person for if we want to recognize an individual, their clothing, their appearance, their background should play no part in their biometric signature. This is what in information leak problem is. A common solution is to use masked self-attention, which basically way sets minus infinity weight to ReID and color token, thus stopping the information leak. There is no direct information leak. But one critical problem arises here is the spatial token are seeing the horizontal spatial tokens are seeing both the ReID and the color token. Hence, ReID token are indirectly influencing the weight of color token and vice versa. A mathematical formulation is shown in the main paper, but visually speaking, ReID, the biometric signature is influencing the weight of the appearance bias and vice versa, which we believe should not be the case. Hence, our design says there should be two sets of self-attention. One isolated with ReID token and spatial token, and one spatial token and color token. And the final embedding can be average of the two spatial tokens. This is in this has the same property as mass self-attention. There is no direct information leak, and it do not affect the weight of each other. And the only alternative to this would be using two transformer branches. That is computationally infeasible. So how do we perform? When we have no color tokens, like the baseline performance, our performance is LTCC 44, PRCC 66, 61.6. When we use traditional tokens with colors, traditional methods of self-attention, the accuracy goes up. So colors do help. Then if we use masked self-attention, the performance slightly goes up even more. And when we use our S2A self-attention, the performance goes even more higher, which basically means that preventing information leak is crucial for the ReID. And the gain in flops, like the gain in computational cost based on two attention step is 4%, which is a reasonably small, decently small amount. Now, regarding the results, we have shown our model CSCI works with a lot of previous ReID transformer-based ReID models with performance improvement ranging from 1 to 7%. And in general, our model surpasses the traditional clothing integer labels for two models, our EVA and VIT base. This is the overall result for all the model. As you can see, almost every single work previously done depends at least on the internal clothing annotation. ReID models have a strong dependency on clothing annotation, which we are removing entirely. And I will see you in Hawaii. Thank you for your time.